Hey everyone, I am Priyanshi Agrawal and welcome back to my YouTube channel. Now we are going to solve the second question of today's Leetcode Biweekly contest 149, which is reschedule meetings for maximum free time 1. Okay, so let's see what is this question and how we can solve it. So in this question, you are given an integer event time denoting the duration of an event when the event occurs from time t is equals to 0 to time t is equals to event time. So you have been given a event time, let's say n, and event can occur from any time between this 0 to n duration. Okay, and you are also given two integer arrays, start time and end time, each of length n. These represent the start and end time of n non-overlapping meetings. Okay, so let me say it's event time only so that you will not get confused. Okay, and then you have been given with the start and end times whose duration is n of n non-overlapping meetings. Okay, and where the ith meeting occurs during the start time I and the end time I. So you have been given within two arrays, start time and end time, in which we are given with the start and end time of the n meetings. Okay, and you can reschedule at most k meetings by moving their start time while maintaining the same duration. Why we need to move the k meetings? To maximize the longest continuous period of free time during the event. Okay, considering the relative order of all the meetings should stay same and they should remain non-overlapping. So finally we need to return the maximum amount of free time possible after rearranging the meeting, and note that the meetings cannot be rescheduled to a time outside the event. Okay, so let's see what they are saying in the question. So we have been given with an event time, k, start time and end time. Event time is the time during which 0 to event time meetings can occur. K is the maximum number of meetings you can reschedule, and you have been given with n meetings with their start time and end time in this array, in these vectors, and you need to rearrange at most k meetings to get the largest free time slot available. Okay, so let's see from this example first. Okay, so in this we can arrange at most one meeting as k is equals to 1, right? Okay, so let's see what we can, how many ways we can arrange this. Okay, so first let's try with this first meeting, as we can only arrange one. So let's try this first. Either we can move it left or right, because the order of the meeting should also not get changed. Okay, so let's try moving this to the 0 to 1, and its duration should also remain same, and then this will become 3 to 5. Okay, so what is the available slot here is 2. Okay, now let's try moving it to the right. So if we move it to the right, then we have available slot 1, 2, we will move it to 2 to 3, and here is our second meeting, right? And here also the longest available free slot is 2. Okay, now we have computed the combinations of this first meeting. Now let's try moving the second meeting. Okay, let's say if we move the second meeting, keeping the first meeting in place, we can move it to left only, because we cannot schedule the meeting after the event time, and it is already ending at 5. Okay, so we can move it to 4, 3, 4, and now what is the maximum longest available slot is? Both here 1 hour long slot available, and here also 1 hour long slot available. So the longest available slot in this case is 1. So among all of these cases, if we consider all of these 3, so which one of these maximum? It is 2, right? So we need to return the longest available free slot. Okay, now let's take some other example to understand this question better, so that how we can solve it. Okay, So let's suppose we have this one. Let me just create it. 1 2 3, it's starting from 0, and let's suppose there is a meeting 2 4, let's suppose it is 3 hours long, 4 5 6, and again there is a meeting which is 2 hours long, 7 8 9, and the event time is 11, right? Cool. Okay, so here event time is 11. Okay, and let's suppose k is equals to 1 only now. Okay, now let's see what we can do. We can either move this meeting to left or this meeting to right, right? Because k is equals to 1 only. Okay, let's create its cases as well. Let's suppose if we have this, if we move it to left, then let's suppose we are moving it to 0, and this is 3 hour long meeting, so it will end at 3, let's suppose, right? And now the available longest slot is, now this meeting is starting at 7, this is occupied, 7 to 9 is also occupied, this is free. Now 9 to 11 is free, right? So what is the longest available slot is 4, right? Cool. Now let's try moving it to the right one. Okay, let's see what happens if we move it to the right. If we move it to the right, it will start from 4 and it will occupy the area till 7, and 7 to 9 there is one more meeting, and 9 to 11 is free slot. Now what is the longest available slot here is? Here is also 4 minus 0, 4. Okay, now we have tried moving this first meeting. Now we can try moving this second meeting to both these sides, either left or right. Okay, so let's see. So 1 to 3, 0 to 3 is empty, 3 to 6 is occupied, right? And then 6 to 9 is also occupied, and then 9 to 11 is available, right? So what is the maximum available slot here is 11 minus 9, which is 2. Now let's try moving it to the right. So if we move it to the right, 3 to 6 is already occupied. If we move it to the right, 6 to 9 is empty, and 9 to 11 is occupied now, right? Now what is the longest available slot here is 9 minus 6, 3. So among all of these, what is the maximum available slot, longest available slot, which is 4. Okay, but what happens if k would have been 2 in this case instead of 1? Okay, so let's see, if k is 2, then how we will solve this question. Okay, so let me just take this again here. Yeah, so how we will solve if k is 2? Let's see. So if k is 2, then we can move both the meetings, right? This one as well and this one as well. Okay, so either we can accommodate this both the meetings in the left or in the right, right? See, here is a gap of 3, here is a gap of 1, here is a gap of 2, right? So if our k is equals to 2, then either we can accommodate these both the meetings in the right. Let's say we accommodate these both the meetings in the right, then 10 to 11 is occupied, sorry, 9 to 11 is occupied by this meeting, and 3 hours, it means 6 to 9 is occupied by that meeting, and 0 to 6, and we have the longest available slot as 6, right? Or even if we have accommodated both of them in the left, then also no issues. 0 to 3 is occupied by the first meeting, 3 to 5 is occupied by the another meeting, and 5 to 11 is empty, and the longest available slot is 6. So what you can see from here is that if we have two, if we can merge at most, if we can move at most k meetings, then we can merge at most k plus 1 gaps, as here k was 2. So what we were able to do is, we were able to merge 3 gaps. 3 plus 1 plus 2 is equals to 6, as you can see here from the answer as well. So the logic behind this question is that if we are moving k meetings, then we can merge maximum of k gaps. Okay, so let's suppose here gaps was 3, 1, 2. But let's suppose if we have some more gaps and some more meetings, let's say 3, 4, 2, 1. Then what we have done is, first initially we can merge these 3 gaps. If we considering k is equals to 2 only, we can move only 2 meetings. And then we will shift this window by 1 again. Then we will consider the sum of these 3 gaps, because we can merge at most k gaps, k plus 1 gaps, if we are able to move k meetings. Then again we will slide this window, then again we will slide this window, and then again we will slide this window. So, and we will take the maximum of all of them to get the longest free available slot, right? Okay, so let's try code this so that you will get we will get a better idea. Okay, so what we can do is, we can first store the start time dot size in n, and what we need to do first is, we need to create a free time vector, like the gaps vector, or we can say, so we are creating a free time vector, and the first free time is the starting time of the first meeting. Before that, or the time is free only, because, and we need to push the further gaps. So how we will push? Free time dot push back. What we can do is start time, as we have already covered the first meeting, so we will start from the second one. Start time of I minus end time of I minus 1. So in this way we will be able to get the gaps between consecutive meetings. And by the end, if we need to capture the end gap as well, so what we will do? Event time minus end time of n minus 1, right? Okay, now what we need to do is, we need to first find the current maximum, like the k plus 1 gaps. First we need to find the sum of k plus 1 gaps, in starting k plus 1 gaps. So what we can do is, I is equals to 0, I is less than k plus 1, I plus plus, and current max plus is equals to free time of I, simple. And then our final answer, max free time is equals to current max. We will initialize it with current max, and then we will simply implement a sliding window logic. I is less than free time dot size I plus plus. We will remove the first element and add the next. We will remove the first available gap and add the next available gap. So it will be current max plus is equals to free time of I, and we will remove the first gap which we have added. So how it will get removed? Free time of I minus k plus 1, right? And we will store the maximum of all these slots in our max free time variable. Max free time comma current max, and by the end of this loop we will return our max free time. So let's try run this. Yeah, it's working fine. Let's try submitting it. Yeah, it's working fine. Okay, so let's talk about its time and space complexities as well. So as we are running on overall one loop only, like we go of n for this, we go of n for this, and we go of k for this. Let's suppose we go of n plus we go of k plus we go of n. So, and k must be less than or equals to n only. Yeah. So overall we can say it as we go of 3n or we go of n. So the time complexity is we go of n, and space complexity will also be big of n as we have created a free time vector, right? So these are the time and space complexities for this question. So yeah, this was all for this question. I hope you get it, but if you still have any doubts, then you can post in the comment section. I will surely try to answer them. Till then, bye guys, see you in the next video.